Hello everyone, welcome to our YouTube channel. Today we are going to discuss about the anatomy of the liver. Let's delve into it.
So as you can see here, we have our liver. So the liver is located in the abdomen, and remember in the abdomen usually have various regions. So the liver is located on our right hypochondrium, the epigastrium, and also on our left hypochondrium. And sometimes in people with hepatomegaly, the liver can extend up to the level below your right lumbar region. So we'll extract our liver so that you can see it, but before it, you can appreciate that this is our diaphragm, separating your abdomen from your thorax, and then your liver at this point will be on your right hypochondrium. These are epigastrium, and some bits of our left lobe will be extending on our left hypochondrium. So we want to discuss about the various parts of this liver. We talk about the lobes, we talk about the ligaments, we talk about the impressions, and some of the relations of this liver. So let's delve into this. So this is our liver anatomically. This is what you will see. If you put the liver in its anatomical position, that will be its anatomical position. You can check that it's first of all wedge-shaped. In addition to that, this liver is the largest glandular organ. As of course you know, the largest organ in the body is the skin. So the second largest organ in the body is our liver, weighing about 1300 grams to 1800 grams in males. But the mean weight of the liver is actually 1500 grams. So I want you to appreciate the various surfaces of our liver. This is actually our anterior surface, which is actually covered by the diaphragm, related to the diaphragm. So ideally that's the diaphragmatic surface. And then on this other portion now, we have our visceral surface. These are our visceral surface. Our diaphragmatic surface is divided into various surfaces. We have the anterior surface here, we have the superior surface here, we have the posterior surface here, and then the inferior surface will be our visceral surface. On this other side, you can appreciate that this is our right surface, and then on this other side we have now our left surface. This is our left surface. Before then, I would like to show you a liver that has hepatomegaly. So this is a liver. You can appreciate that this liver is big. It has hepatomegaly. You can appreciate that even this right lobe of the liver is actually about 7 to 8 times larger than the left lobe. And ideally, in our normal liver, our right lobe in relation to our left lobe is about 5 times, but in this one you can appreciate it's about 8 to 7 times larger than our normal liver. So this is a liver that has hepatomegaly. So at this point you can appreciate this is a falciform ligament. On this side we have our right lobe, on this other side we have our left lobe. So these falciform ligaments divide the liver anatomically into right lobe and our left lobe. At this point you can appreciate this is a groove for the inferior vena cava, and then there is a cystic fossa. So if you want to divide our liver into our functional lobes, we'll divide them according to this a line connecting the groove for inferior vena cava, and that line will be going downwards to connect with our cystic fossa. But by that virtue, we'll be having our right lobe and our left lobe. In addition to that, you can appreciate that at this point you can appreciate this is a quadrate lobe, and our caudate lobe at this portion will be on our left lobe. So if you want to divide the liver in its functional components, functional lobes, you can appreciate you just have to draw this line connecting the groove for the inferior vena cava together with the cystic fossa, and have the two right and the left lobes. In addition to that, now we want to talk about the various impressions. So I want to take us through on the visceral surface. On the visceral surface, we start with this. This is actually the impression, the relation of our esophagus. So the esophagus together with its covering will be located at this point. Then you can appreciate this will be our gastric impression. The gastric impression will be here. So our stomach will be lying posterior to the liver. On this other end, I want you guys to appreciate this will be the impression for the pylorus, and in some people will have the impression of our first part of our duodenum. So we continue ahead and see that this will be the impression for the duodenum, and then at this point this will be our colic impression. So our hepatic flexure will be here. Then at this point we'll be having the impression for our kidney, so this will be our renal impression, and then at this point we'll be having the suprarenal, the right suprarenal gland will be located at this point. So just to recap, we'll appreciate that this will be esophageal impression, gastric impression, pyloric impression in some people. You'll have the first part of the duodenum being there. Then at this point you can appreciate this will be our colic impression, renal impression, and the suprarenal. So this is the falciform ligament. On the falciform ligament you can appreciate on our left part of it you have our left leaf, and on this other side you have a right leaf. So this left leaf becomes our left triangular ligament, and this right leaf goes ahead and becomes our
coronary ligament.
On this other side, I want you guys to appreciate this ligament here. This is ligamentum venosum. Ligamentum venosum is actually a remnant of ductus venosum. On the other side, we appreciated this falciform ligament. This falciform ligament, on the free margin, you can appreciate this is our ligamentum teres hepatis. So this is the falciform ligament, of which on the free margin of it we have our ligamentum teres hepatis. So ligamentum teres hepatis, I said alluded earlier, is a remnant of our left umbilical. This is actually our inferior vena cava at this point. I want us to appreciate this are actually our hepatic veins. So hepatic veins will drain into the inferior vena cava. So we want to discuss the support of this liver, given the fact that liver is a very heavy organ in our body. So what maintains it in the region of the right hypochondrium and in our epigastrium? So one of the factors that maintains the liver in its anatomical position is actually the presence of our hepatic veins being attached to our inferior vena cava, and actually that's the main stability factor for our liver. The other factor is actually our various ligaments. So our falciform ligament, our ligamentum venosum, and our coronary ligament, they just attach the liver to the body wall and also to the diaphragm. And the last thing that we'd like to discuss about actually is, given the fact we have the abdominal muscles, when these abdominal muscles they contract, they create abdominal pressure, and that abdominal pressure maintains the liver in its anatomical position. So the three factors that maintain the liver in its anatomical position, first of all, is presence of these hepatic veins, the hepatic veins joining into our inferior vena cava, which is the inferior vena cava is this one here. Then we have our various ligaments, the falciform ligament, the ligamentum venosum, the ligamentum teres hepatis, the various
coronary ligament,
which now join the liver or attach the liver. It's first of all into the lateral body wall and also on our diaphragm, and the last factor being the abdominal pressure, which are being created by abdominal viscera and the abdominal muscles, just to maintain the liver in its anatomical position. Just to appreciate the various bare areas of the liver, and the first bare area of the liver is this one. This is the first bare area of the liver. So the bare area of the liver, we have this is the first area of the liver. A point to note is that this point will have portocaval anastomosis. Yeah, so portocaval anastomosis, of course, you know, it's when you have anastomosis between our portal vein and also the systemic veins. Another bare area that we have, so this is a cystic fossa at this point. So if you try to reflect the gallbladder, we'll see that fossa will not be lined by our visceral peritoneum. The other part that will be having, that will be a bare area actually, is this fissure here, the fissure for ligamentum venosum. We'll appreciate that it won't be having our visceral peritoneum. And our other bare area of the liver is that this, on the region around the porta hepatis, below it will be having a bare area also. So for our four bare areas of the liver is that we'll be having this bare area around this point, around the ligamentum venosum fissure, and then on the cystic fossa and just below the porta hepatis. Another point to appreciate is that this is our gallbladder. This is our gallbladder. You can appreciate this is the fundus of the gallbladder at this point. This is and then this is the neck of the gallbladder. At this point, you can appreciate that this is our porta hepatis, In our porta hepatis, we need to appreciate the structures that either go in or out of the liver. So this is our portal vein. This is our portal vein. We need to appreciate another structure at this point, and this here is our cystic duct. Remember, the cystic duct usually joins our common hepatic ducts to become the common bile ducts. Then the other structure that you need to appreciate is actually this. So this is our hepatic artery. So remember, hepatic artery, the hepatic artery proper will divide into two to give you the right and the left hepatic arteries, and then the right hepatic artery will give you the cystic artery that goes to your gallbladder. So I want us to discuss a little bit of the embryology of the liver. So the liver itself has parenchyma, and then it has a capsule. So the capsule of the liver is known as Gleason's capsule, and this is the Gleason's capsule. So the Gleason's capsule is actually made by our visceral peritoneum. So the capsule of the liver, the Gleason's capsules, comes from the mesenchyme surrounding the liver parenchyma that is developing. In addition to that, you'll get some portion, the upper part of our liver coming from, of our capsule of the liver coming from septum transversum. Another thing to appreciate is that the parenchyma of the liver will be coming from the endoderm of the duodenum, and that's the reason why our common bile duct drains into our duodenum, the second part of the duodenum. So the parenchyma of the liver will give you, first of all, the liver diverticulum. Then the liver diverticulum will divide into two to give you the pars cystica and pars hepatica. So the pars hepatica is the one that will give us the liver itself. So our hepatocytes and our cholangiocytes will be coming from the liver. Then our hematopoietic stem cells together with the Kupffer cells will be coming from the septum transversum. So that's about it. Kindly like, share and subscribe.